students, a very warm welcome to RITU maths classes. Today we have taken the topic of area of a triangle from the chapter Determinants for class 12th. In lower classes we have already studied, especially in 10th class, area of triangle ABC whose vertices are x1, y1, x2, y2 and x3, y3 is such a long expression, and we used to do it in a chain formula. So this expression is actually the expansion of the determinant half of x1 y1 in the first row. Since we are working in two dimensional, so we have to write down 1 in the last entry, x2 y2 1 in the second row, x3 y3 1 in the third row. If you expand this determinant, you will get the same expression which you have done as the area of triangle. It means the determinants are giving you the formula for the triangle of ABC as well. So it is an application of determinants. So let's start solving with some of the questions with this formula. Here are some remarks. Let's go through this. First is, since area is a positive quantity, we always take the absolute value of the determinant. As you know, area for a triangle, area of any figure, area of quadrilateral is always positive. So in case when you solve the area of triangle, you get negative. So you have to take care that you take the absolute value of the determinant. That is, it can never be negative. Absolute value means to say modulus value. Second part, if area is given, in case you have been given the area already given and you have to find out some scalar, then use both positive and negative values of the determinant for calculation, because actually we do not know that particular scalar for which we are solving was originally positive or negative. So we have to take two cases, positive as well as negative. The area of a triangle formed by three collinear points is 0. This is simple, that if 3 points lie on the same straight line, they are known to be collinear, so they do not form any triangle. When they do not form any triangle, so obviously the area of the triangle that is considered to be formed by those points will be 0. Let's start doing the example 17. Find the area of the triangle whose vertices are 3, 8, -4, 2 and 5, 1. Area of required triangle will be equal to half of, the first vertex is 3, 8. The last entry in the first row will be 1. Second row will be comprising of the second vertex, -4, 2. The last entry would be 1. And third row is given by the third vertex, 5, 1. Last entry 1, as we had discussed in the formula. Now expanding it along R1. 3 into 2 minus 1 -8 into -4 -5 plus 1 into -4 -10. You can expand it along any of the rows or columns, but I have done it along R1. That is quite simple. 3 into 1 -8 into -9 plus 1 into -14. That gives us 3 minus plus 9 8s are 72 minus 14. 72 plus 3, 75. 75 minus 14 gives you 61 upon 2 as such. That is 30.5 square units. Let's take some more questions to understand the same topic. I've taken up example 18. It has two parts. I'm going to read the question. Find the equation of the line joining A and B using determinants. You have done in class 11th how to find out a line using two-point form, but I cannot use that two-point form here because I have been told to find out the equation of line using determinants. And second part, find K if D, K, 0 is a point such that area of triangle is 3 square units. I'll be dealing with the first part first of all. I have to find out the equation of line joining the points A and B. If there is a line joining the points A and B, many other points will also lie on it. So I am going to take a general point, any point P, which lies on that line. So let Pxy be any point on the line AB. If P lies on the line AB, it means I can say that the points A, B, P and collinear. They are lying on the same straight line, so they are collinear. And if the points are collinear, area of triangle formed by these 3 points must be 0, as we have discussed in the beginning of this video. So half of A, 1, 3. In the first row, 1 last in the constant. B, 0, 0, 1, and then the vertex of P, x, y, 1 should be 0. This 2 is a common denominator, goes into cross multiplication, 0 into 2, 0. And here I am going to expand the determinant through R1. 1 into 0 minus y minus 3 into 0 minus x plus 1 into 0 minus 0. So that is 0. I am going to expand it. 1 into minus y minus 3 into minus x. 1 into 0, 0. That is minus y plus 3x is equal to 0, which can be written as 3x minus y is equal to 0. So this will be a line which will be satisfied by these both points A and B. If you want to check, you can check it by putting the points A and B in it. Let's solve for the second part now. The second part says find K. If this point lies on, actually is a point such that the area of triangle ABD is 3 square units. So according to question, area of triangle ABD is 3 square units, and if we make the area of triangle ABD, it is half of determinant of, I've taken the first row from A, taken the second row from B, and last row would be taken from D as it is given. The vertices are given K, 0. So I have taken this. This 2 goes into cross multiplication, becomes a 6. And here I am going to expand the determinant with the first row. 1 into 0 minus 0. You can see very easily. Minus 3 into 0 minus k plus 1 into 0 minus 0. That is 0. But here I have to take care of one thing. As we had discussed in the remarks, if area of the triangle is already given to me, we have to take both the cases, positive as well as negative, for calculation. So whenever you are going to solve for variable, you do not know actually the variable was positive or negative. So please take both cases, plus minus. So let's solve it. 1 into 0 minus 3 into minus k plus 0 is equal to plus minus 6. It gives us 0 minus minus plus, that is 3k is equal to plus minus 6. So that gives us the value of k as plus minus 2. So if you have liked my video, please do like it and share it with your friends, and do not forget to subscribe to my channel RITU Maths Classes. Thank you.